Hello class again, and welcome to this particular video. And in here we're going to be looking at a line on a graph and what makes that line to be different from a line that is on a different graph, and this will be mainly linked to the slope of the line. So we're going to focus mainly on slopes of a line, and we know that y is equal to mx plus b is the equation of a line, and we know that to determine the slope you can look at the graph and figure out how the slope is actually established, or you can actually just look at the equation of the line, recognize that m is actually the slope, and then you go from there. Easy. So in here we see that m can be determined in three ways. That is why I have the triangle. So it's like, okay, I can determine this mainly based on where or what cases that these questions might be presented. So first one is if a question is presented to you in the form of a coordinate, like, okay, something is running at that particular time and this is the distance covered, and at a different time this person actually covers another distance. So in here you have 2 points already given to you. So you have your y and your x. So your x1, y1 is for 1 point, and the other point is your x2, y2. So if you're solving this algebraically, what you see is that if you subtract your y1 from y2, you get a number, and if you do the same thing for your x, in this case x1 minus x2 minus x1, you actually get a value. And once you divide the change in y by the change in x, you'll be able to determine the slope algebraically. So the second case is through table of values, and in this case we notice that in the x column we have constant change in the x, and the same thing is applicable to the y, a constant change in the y, which gives us our change in y divided by the change in x. And once you do that, you'll be able to determine the slope of that particular line if given tables. And finally here is through a graph. If you recognize that a line is given to you already, all you need is to pick a point or pick 2 points and figure out how much you're going to rise to how much you're actually going to run to that particular line. And once you notice your conversion, rise could be positive or negative, and the same thing is applicable to the run, which could be positive or negative. You should be able to figure out the direction that that particular line is actually going, which represents the slope. So once you have that taken care of already, what we're going to do specifically in this particular lesson here is to highlight the commonalities between lines, mainly looking at the slope. So what I want you to do is looking at these particular questions here. We have 4 graphs, and looking at these 4 graphs, there are various characteristics that makes them unique, and how unique these graphs are mainly looking at the slopes. So what I want to do is make a guesses on what categories these graphs represent related to the slope. First, is the slope negative? Is the slope positive? Do they have 0 slopes, or we're not sure on what the slope is for one of the lines? So once you determine that, we're going to determine using mathematics what each slope actually represents concerning the characteristics of that line specifically. So looking at case 1 here, we see that the line is actually pointing upwards and towards the right. So what is this particular slope of the line, or what is the equation of this particular line? So first is that we need to state the knowns, which means that first we have to pick points on that particular line to determine the equation of the line. So looking at the knowns, we picked points. The first point here is the y-intercept, which is equal to 3. Therefore b is positive 3, and the point in this case that is along that particular line is actually that blue point, which is -3, -1. And by so doing, we have 2 points, and we can figure out graphically what is the slope. So to determine the slope of that particular line on the graph, we need to perform the rise over run, which means that is how you determine the slope. And we know that the rise starting from the blue point is actually needed in here, and starting there we actually are going to go 4 units up. And if you're going 4 units up means positive, and that is one step that is required in order for you to arrive at the next point. The next point is the y-intercept. Now we're not at the y-intercept yet. To determine to get to the y-intercept, we need to make another trip. In this case is a run, which is by how many units? Now this unit is just going how many steps to the right? 3, which means that we're going to move 3 units to the right in our 4 way to finally arrive at that particular y-intercept. So therefore we have positive 3 for our run, and therefore our slope will be positive 4 divided by positive 3, which gives us positive 4 over 3. Therefore, to determine the slope, we need the equation, we need 2 things. We need the slope and the y-intercept. We know the y-intercept to be positive 3. You put that in place of b in your equation of the line expression, and your m, you put 4 over 3 in place of m, and therefore your equation will be y is equal to 4 over 3 x plus 3. So that is about it on determining the equation of a line based on this particular step, or I would call it merely based on case 1. Now let's look at case 2, which is an S graph. And what do you think the graph equation will look like? Will it have a positive slope or a negative slope? So in this case here, we see that the line is actually pointing up but towards the left side of the graph. So if it's going up but to the left, it means that it's not the same as case 1 graph. Now let's state the knowns, and looking at the knowns, we see that picking a point, in this case we're picking the first point, which is the y-intercept, which is in this case -3. We know that b is equal to -3. Therefore the second point to pick is the blue point there, which in this case is actually at -4, 3. Therefore performing the rise over run, which means that going from that first point to the second point, we have to perform that particular steps. First, what is the rise? In this case, it's actually going down 6 units. Therefore, down is negative by conversion, and then you're moving how many units to the right? 4 units, maybe. Let's see whether it's 4. So if we have 6 for our rise, how about our run? Let's see what we got there. Yay, it is 4 to the right. Therefore, it is a positive value, positive 4, because by conversion, right, run is positive. So therefore, if you find your slope, to do that you have to divide your rise by your run. Therefore -6 divided by positive 4 gives us -6 over 4, or you reduce that gives us -3 over 2. Therefore, putting m and b in this particular equation of a line, we'll be able to determine our equation to be y is equal to -3 over 2x minus 3. So that is it for case 2, and what we're going to do is to look at case 3, which is a vertical line or horizontal line, sorry, and the case 4, which is a vertical line. And looking at this, what do you think is going to be interesting here? Now in those cases, looking at case 3 specifically, we notice that we're just running vertically, right, or horizontally, sorry. If you're running vertically, there is something that is changing, but there is nothing changing on the other case. And in this particular point, Once we pick a point, in this case we're picking the y-intercept, we notice that the y-intercept here is positive 5. Therefore we know our b already, which is positive 5, that is taken care of. Now we're going to pick another point horizontally. So if you pick another point horizontally that's along that particular line, in this case that particular point is 4, 5, we can actually determine the rise over run, which is used to determine the slope. But what we see here is that there is no rise because we are actually on the horizontal line. So therefore it is 0 because there is no change in y. However, there is a run because yes, of course, you're running horizontally and you're not jumping. Yes. So therefore it means that going from one point to another, you're going positive 4, which means to the right. So therefore it means that our run is positive 4. And once you have that established, it means here that an egg on top of a house, hey, the egg is cool and nice. So in this case, yes, m is equal to 0. Anyways, that's the way I established in my head how 0 is influencing division. So it's pretty much my way of thinking. So in this case, we know that m is equal to 0. So therefore, if m is equal to 0 and we know our b is positive 5, if you put those in the equation y equals mx plus b, we will get the equation of this horizontal line to be equal to the y-intercept, which is positive 5. So this is different from case 1 and case 2, and case 3 is going to be different, of course, from case 4. And looking at case 4, what we see is a vertical line, and if it's a vertical line, not a horizontal line, this is going to be different because this time we're jumping, right? We are not going, we're not running. It's like you're on the wall and you're jumping up and down. You don't want to jump horizontally because you're pretty much going to knock down the wall. So think about it that way, you're jumping up and down. So in this case, once you actually perform case 4, what we see is that the line is actually having no y-intercept, and if it doesn't have a y-intercept, b is equal to none. So there is no y-intercept. Therefore the next thing you want to think of is, oh, okay, since there's no y-intercept, how about the x-intercept first? What is the value for the x-intercept? Oh, yeah, the x-intercept is actually, in this case, -3. And once you have that, we have a point already. But now we need to find another point. So we pick another point along that line. And in this case, the coordinate of that particular point is -3, -4. We notice that the x doesn't change, but the y changes. So therefore, in this case, we see that, hey, if m is equal to rise divided by run, the rise is actually going to be a number. Therefore, in this number is a change in the y because you're going up and down. Of course, that exists. So in this case, we're going down. You can also put it up. It doesn't matter. You're good for there. So in here, we're going -4 because we're going down units. So therefore, our rise is already determined to be -4. However, how about the run? What we see here is that the run doesn't exist, so it's just 0 because there's no change in the x remains the same. So therefore, if x is equal to 0, what does that tell us about this particular slope? It means that the slope, there is no slope in here. That is your answer in there. And therefore, what is the equation of this particular line? The equation is pretty much the x-intercept because it is vertical, and the vertical line is parallel to the y-axis. So in here, we have the x-intercept to be equal to -3. So once we've seen these big broad ways of determining the slope of lines that are different from each other, one we notice is that x or the slope is positive, 2 tells us that the slope is negative, 3 tells us that the slope is actually 0, and finally the other one is that the slope is actually there is no slope. how can you categorize this based on a conclusion here? Now we see all these lines that we dealt with just currently, and based on the conclusions, we see that looking at the slopes, mainly rise over run, case 1 is different from case 2 and case 3 and case 4, and they're all on different categories, or they are unique. So how can we categorize lines that are looking like case 1? Now this in this case tells us that if you have a slope that is determined when your rise is up and your run is to the right, or you have down to the left, you will always get a positive value for m, as you see in the equation. Therefore m will always be a positive value, or m is a number that is always greater than 0 on the number line for we to have, in conclusion, a positive slope. Now looking at case 2, we need to have a up divided by a run, which is actually to the left, or we have down to the right, in order for we to create a negative slope. Therefore m is a number, or any number that is less than 0 on the number line, in order for we to actually have a negative slope that looks like that particular line in case 2. Now case 3 tells us that if you have no change in your y but you're going to the right, or no change in y, which is 0, divided by to the left, you always have a 0 value. Therefore m is always 0 in a case when you have a horizontal line. Therefore this tells us that we're going to have a 0 slope always when you have a horizontal line. Don't forget that. I won't emphasize this more, please. If you have m is equal to 0, your slope is always 0, which is a horizontal line. So once you have that taken care of, a vertical line, of course, is the opposite of your horizontal line. And what we see here is that even though you go up or down, but your x is equal to 0, there is no slope, and therefore m is no slope. Therefore you have an undefined slope, which tells us that your equation of that particular line will be pretty much the x-intercept. So since you have all these taken care of, I want you to remember these 4, and when you're given questions either through equations or either on a graph, you should be able to look at the slope and tell me whether it is positive or negative, whether it is a 0 slope, which in that case it is horizontal, or it is a vertical slope, which is in this case undefined. And once you have that, we're going to look at the 3 and the 4 cases, which involves the horizontal slope first, and later we'll look at vertical slope and associate those with how the table of values look like. So in here, looking at the horizontal line, which gives us the 0 slope, we notice that by observation the x values remains different. However, looking at the y's remain the same, which in this case is b's. So what we notice in conclusion is that that b value that remains the same is the y-intercept, or you put it this way, it is the y value that is the equation of the line. So if you're given coordinates, or you're given a table of values, and you see that the y's are the same and your x is changing, your answer for the equation of the line is the number that remains the same on the y, which means that, hey, I recognize that the y remains the same. This must be a horizontal line by observation. So if you observe any data given and you see that your y's remains the same, you have to conclude that on the graph it is a horizontal line. So once you have that, an example of this is, in this particular case, we have all the x different. We have 2, -2, -4, but your y's is 5, 5, 5. Therefore, your y is equal to 5, which tells me that, hey, it is a horizontal line. Now, what do you think undefined slope, which is a vertical line, states or observation looks like? Now, you should guess it right. Yes, if I have all the y values changing by observation, looking at the table, your x values will remain the same. So if t is a number that repeats for the x, that t is actually the x-intercept, and that represents the equation of the line x is equal to t. And this actually tells me that in here, this is actually a vertical line, which is an undefined slope. So an example is, given this particular case, you notice that the y's doesn't change. We have 2, -2, -4. However, your x remains the same, which in this case is -3. It means here that x is equal to -3, which is actually highly linked to that particular line on that particular graph. So that is about it for this particular video. Hope you're able to understand this. The big takeaway message is, if I'm given an equation of a line, I need to look at the m's, and from the m's I should be able to categorize the line as either positive or negative slopes. And if I don't have an m where y is equal to b, that tells me that I have a horizontal line, which is horizontal slope, or a zero slope. And if I don't have any y or m, it means here that I have an undefined slope, which means that I'm going to have a vertical line. And that is actually what you need to take away from. You're going to have a couple of questions on your Harpara space to just get you comfortable identifying slopes and how that translates to the look on a graph. So that's about it for this particular video. Please hit the comment down below, let me hear your thoughts. By that way I can talk to you soon, or send me an email. By that way we can actually talk more via Google Meet. All the same, stay smart and believe in yourselves.